we're going to discuss functions. This is an introduction to this subject, and my approach is a little bit different than, say, the books. At least it starts out a little bit different. They do converge. We do cover the same things. But let's start out with something that I'm going to call the phone function. Now I've got a set of ordered pairs, all these letters and corresponding numbers. This is what you would type in when you're typing in those designer phone numbers that you see all around the town on buses, 1-800-lawsuit, 1-800-I-SUE-BIG, and the all-important 1-800-who's the father, that kind of thing. So there's this nice correspondence between letters and numbers, right? So I figure that in a couple of years, maybe I'll start my own service, 1-900-SOS-MATH, $3 a minute. I'll answer all your math questions, etc. Make a fortune, retire early. What number would you dial to dial math? What number goes with that word? So 628, and then what? 4. 6284. There you go. Kind of nice the way it works out, right? You give me the letter, I can give you the number. So there's a nice correspondence. If you know what the input is, you also know what the output is. So that's good. But let's flip things around. Let's look at this next set. It's called the phone relation. And here I'm turning things around. The number comes first, and then the letter. So suppose I'm getting a little bit concerned. No one stops by my office. No one calls. I'm feeling lonely. And I want to encourage you to call. So I want to come up with the word that you can use to remember my office phone number, 2678. Let's start with a 2. What letter goes with a 2? B or C or A, really? So which one? I mean, you've got your choice, right? And that's something that's kind of a downfall of this set of ordered pairs, is that when I give you the input, you don't necessarily know what the output is. If I give you the number, there's a choice of letters. And that's kind of a bummer because I'd like to know exactly what letter goes with this number. But you don't have that correspondence. So something about this is different than what we had up here. Here, if I tell you the letter, you know exactly what number. Whereas down here, if I tell you the number, you don't really know the letter. The difference is one of them is a function and one of them is just a relation. And we want to try and understand that difference. So let's look at a couple problems in the book and also look at some definitions. Definitions of a function. A function is a relation in which no two ordered pairs have the same first coordinate and different second coordinates. So in the phone function, none of the first terms are repeated. So we don't have any problems. In the second one, yeah, you've got 2 multiple times. And for these multiple values of 2, we've got different y coordinates. Or the same first coordinate has different second coordinates. So it fails to be a function. Now this idea of a function is so important that I'm going to give you 3 different definitions of it, 3 different versions of it. You work with whichever one you're most comfortable with. A function is a relation in which each unique first coordinate has a unique second coordinate. There's nothing like this. No first coordinates that have multiple second coordinates. A function is a relation in which each x corresponds to exactly one y. There's a lot of ways to look at it. Let's get a look at it visually here with a few problems in the book. Let's take a look at problems number 21 and 22. Let's start with problem number 21 here. does this look like it represents a function? If I give you the value of x, do you know exactly what value of y goes with each value of x? Yes or no? What do you think? No. Because x equals 4 has multiple values of y. It could be 2, 4, or 6. So this one's not a function. How about problem number 22? If I give you the value of x, do you know what the value of y is? Yes. It's okay to be many to one, not one to many. So this is okay. This one's a function. 22 is a function. 21 is not a function. Let me introduce some more definitions and some notation here. Let's talk about something called the domain and the range. The domain is the set of all the x coordinates of a relation. Both of these sets of ordered pairs are relations. That's what a relation is any set of ordered pairs. But the domain is just the x values, or the first coordinate in this set of ordered pairs. So our domain here is a set of A, B, C, all the way up to Z. So that's your domain of the phone function. Now we can't do something for the first coordinate and not do something for the second coordinate. So the range is the set of values that you see in your second coordinate. So what's the range here for the phone function? Two, 3, anything else? So it's the numbers 2 all the way up to 9, just the integer values. That's your domain and range for the phone function. Why don't we repeat that calculation down here for the phone relation? Let's again do the domain and range. This time I want you to try it and compare your notes with a neighbor. Let me hear some chatter. Compare notes with a neighbor. Make sure you guys both have the same answers. Jenna? Compare notes. Make some friends back there. Mark, you might have to travel a little bit. Make a friend. Tovarish. Yes.
Domain doesn't have to be the letters all the time, right?
It's just the first coordinate. So yes. Sabrina? Did you make a friend? Okay, good. All right. Sabrina, what's the domain here for this one?
2, 3, 4,
Good. All the numbers, the integer numbers 2 through 9. Nice. How about the range? Who wants the range? Good. All the letters A to Z. So basically the domain and the range switched from one to the next. That's okay. The idea is just to get comfortable with this idea of domain and range. Now, let's move down here and look at a couple examples. So, again, we're going to look at domain and range. So let's start with the domain of this relation. What's the domain of this relation? Anyone on? Good. 2, 4, 3, and 5. I'm going to take the time to write those in numerical order. You don't have to get this one right. Not worried about that. So good, we got the domain. Someone else for the range, please. All right. 4, 3, 5, and 1. So 1, 3, 4, and 5. Now the big question is whether or not this is a function. Is this a function? If I gave you the value of x, do you know what the value of y is? So if x is 2, y is 4. If x is 3, y is 5. You know exactly what the value of y is once I give you the value of x. So that's good. That's a good thing. This is a function. Let's try the next one. Same game. Domain and range. So the domain here. Megan? What's the domain? Good. 1, 2, and 4. We don't have to repeat it twice. It's enough to list it once. Although I wouldn't mark it wrong if you wrote 1, 2, 2, 4. Good. Someone else for the range. Yeah, 5 and 3. Is this a function? No. Now, let's see here. Why isn't this a function? Yeah, there's a couple different x's that lead to the same y value. So, in particular, right here, you've got the same value of x, 2, having different values of y. By the way here, I think there's a little bit of a typo here. That point should be up here, the 0.45. All right, but that doesn't really change our conclusion on this. This isn't a function, but it'd be nice to have an easier test rather than sifting through this and figuring out, gee, okay, you've got 2 inputs that have different outputs. The same input has different outputs. Same value of x has different values of y. An easier test is whether or not this thing passes the vertical line test. So what's the vertical line test? That's at the bottom here for you. A graph represents a function if any vertical line intersects the graph at most once. Now there's a couple of different ways you can state the vertical line test. You can state it positively like that, or you can state it negatively like this. If a vertical line intersects the graph more than once, then it's not a function. So it's up to you which way you're most comfortable with it. But you can see pretty quickly that if a vertical line intersects your graph twice, then you've got the same x coordinate with different y coordinates. It's not a function. So it's a quick, easy way to tell whether or not you've got a function. If your vertical lines intersect the graph at most once, it is a function. Yes, sir?
So, if it's not function, x should not have a vertical line with y, right? Is that what you're saying?
What I'm saying is that,
Have 2 points in a row.
yeah, you can't have 2 points in a row on a vertical line. Now take a look at this over here. All our vertical lines that I can draw How many times do they intersect the graph? Just once. Or none at all, right? I mean, all the lines I can draw in between don't intersect the graph at all. But those vertical lines only touch the graph once. So it is a function. Here, you had a vertical line that intersected your graph twice, so it's not a function. Let's practice this one some more here. So, flip to the back side of your handout. And let's crank off problems 56 through 62, the even number problems. Decide if it is a function or if it's not a function. Let's look at problem 56 to start with. Is this a function? Yes or no? Yes, it passes the vertical line test. No matter what vertical line you try and draw through this, it's only going to intersect the graph at most once. So this one is a function. Let's move over to the next one. Is this one a function? No. Good. So you look and pretty quickly you can discover that a vertical line intersects this graph twice for quite a few different vertical lines. So it's not a function. Not a function. How about down here to problem number 60? All right, got to vote for it is a function. Do I have a second?
Yes.
All right, motion carried. It is a function. I like that, math by democracy. Cool, we'll vote on it, right? It is a function. All the vertical lines you choose to draw are going to intersect this graph at most once. And because of that, this is a function. How about the last one? Function, yes or no, all together? Yes, well done. All right, is a function. Now, sometimes on an exam, I'll test you on this by asking you to draw something that is a function and something that's not a function. Now, for my sake, draw something other than just a straight line. Don't draw a straight line. Use some imagination. God, have pity on me. I got to grade like 60 of these things, all right? I don't want to look at a bunch of straight lines. So be creative. Draw something that's a function. Draw something that's not a function in each of these, and then share with a neighbor. Critique each other, all right? The friend you just made a few minutes ago, make that friend again. Interact with your fellow human beings. It's healthy. want to see some creative graphs here. Okay.
That would fail the vertical line test here and here. So you can't have a vertical line because it would fail. The vertical line is failing on the line test. Very nice, is that right? It's okay. It passes the vertical line test. You're okay. So then just this, and this. Just the parabola? Okay, that's fine. Oh, very good. First one, not like that. Failed vertical line test because that vertical line would intersect this and points. Same thing. That was that would be function. You have to draw something to pass it on the test.
Okay, so you're looking for something that passes the vertical line test. Here's something simple that passes the vertical line test. Here's something that doesn't pass the vertical line test. As long as at least one vertical line would intersect the graph at more than one point, here, here, and here, for instance, then it's not a function. It really only needs to fail it, at one point, here and here. If it fails at once, it's not a function. Now, the other part of this section is function notation. And it's a different way to write things. It's very, very handy. It'll be years before you can really fully appreciate just how clever this notation is and what it allows us to do. But let's start with the basics of function notation. Function notation. So that's stuff like you'll see in problem 36. F of x is 1 minus 5x. Now realistically, f of x is really kind of replacing our y. Up until this section, you would have seen this written as y equals 1 minus 5x. But here's our new notation. And let's see what we can do with it in terms of understanding it and making some evaluations. We'll start with part A, which asks us to calculate f of 0. So f of 0. So I'm replacing this x here on the left-hand side of my equation by a 0. And I have to do the same thing on the right-hand side. So f of 0 would be 1 minus 5 times 0, which is a 1. And that's it. Basically, what they're doing is they're giving you a new input. This is your input, and what you get when you do the arithmetic here is your output. Part B, similar kind of stuff here. This time we have f of negative 75. But the idea is still the same here. It's going to be 1 minus 5 times negative 75. Let's think, that's what, 375? So this turns into 1 plus 375, or a total of 376. There's two more kind of like this for this part of for problem number 36. The first one is f of 0. What is it? Oh, negative 2, right? Let me just double check here. No, 0.2. Yeah, f of 0.2. There we go. I was looking at the wrong thing. F of 0.2. What's 5 times 0.2? 1. So you get 1 minus 1, which is 0. One last one like that. F of negative 4/5. This is a good one. A little practice with some of your fractions. 1 minus 5 times negative 4/5. Two things are going to happen. One is that the negative times a negative gives you positive, so it's 1 plus something. And also, hopefully you see that there's a little cancellation here, right? 5 and 5. What's that leave me with? 4. So there you go. Essentially, you could graph this thing now. What we've come up with are a bunch of pairs of points. You could fill in a little t-table based on what we've done here in terms of x is the input, y is the output. So when we input a 0, we output a 1. When we input negative 75, we output 376. If we input 0.2, we output 0. And if we input negative 4/5, we output 5. So you could plot those pairs of points, and that would go ways to showing you what the graph of this function looks like. That's not our goal right now. Our goal right now is just to get comfortable with this notation. Let's do a couple problems from number 40. You will be given the function. You're not asked to try and come up with the function in these types of problems. In the case of problem number 40, it's f of x is the absolute value of x plus 2. Let's try part A, first of all. F of 0. And let's also throw in part D. F of negative 99. So f of 0 and f of negative 99. What's f of 0 going to give us? 2. Get the absolute value of 2, which is 2. How about f of negative 99? It would be the absolute value of negative 97, or negative 97, which is positive 97. Let's try a couple more here. Problem number 42, changing things up a little bit. We've got a new function. This time it's g of x is x to the 4th plus x. Okay. So the first thing is to find g of 1. There's something a little bit different about problem 42a here as opposed to some of the previous problems. Can anyone put a finger on it? What's different here? It is a function. There's an exponent. That's one thing. All right. F is, we replaced the name of our function as g of x. There's something else that's a little different. There's a couple different places you have to put in this one value of x. So I've got to put in a value of x here and a value of x here. Putting in the same value twice. What's 1 to the 4th power? 1. Plus 1 is 2. So g of 1 is equal to 2. Let's take a look at let's try g of negative 2. Why don't you try g of negative 2? First one with the right answer gets to do an extra 10 problems of homework. Hurry, hurry. Don's working hard. Jackie's on his tail. What'd you get? Don't be afraid to answer. I'm really not going to make you work. All right. Negative 2 to the 4th power should be a positive 16 plus negative 2 would be 14. Yay. How many of you got 14? All right. Good. Do we need to do another one like this, or are you comfortable with those? Let's finish up with problem number 44. S of x is x minus 8 quantity squared. Let's start with part B. Go to the challenging stuff right away. S of negative 8. You have to be careful with these things. If you notice, when I plug into my expressions, I typically do so using parentheses. And that's especially true if I've got a negative number. So I've got negative 8 minus 8 squared. What's negative 8 minus 8? Thank you, negative 16. Now when I square a negative number, I'm going to get a positive number. So the only thing left to figure out is what's 16 squared? 256.
32. Oh, no.
It's all right. It's all right. 256. Why don't you try part D here? S of 12. Mark, what'd you get for S of 12? Good. 12 minus 8 is 4. 4 squared is 16. Well done. For homework. Try 15 through 29, 35 through 61. That's section 3.8. Remember, you've got a test this Monday. to cover up to and including this stuff.